Okay, everybody, here are the day one notes from the new chapter, finite arithmetic and geometric sequences. So A, the notation A sub n refers to any term in the list. The fifth term would be considered A sub 5. The 21st term would be indicated by A sub 21. We can also talk about the position a term is in a list compared to another. Use the sequence 3 halves, 3, 6, 12, 24, 48, and 96. So if A sub n is 24, then A sub n minus 1, so this term here, A sub n minus 1, refers to one less term than that n. So I gotta go backwards 1. So 24 is right here. So the term before it, which would be A sub n minus 1, would be 12. And then your A sub n plus 2, that would be 2 terms after the A sub n. So if A sub n is 24, 2 terms after that would be 96. And then A sub n minus 3 would represent 3 terms before the A sub n. So 3 terms before 24 would be 3. So now, if the A sub n is equal to 12, then the A sub n minus 1 refers to the term that's before it. So before the 12 would be the 6. A sub n plus 2 would be 2 terms that are after the A sub n term. And if A sub n is 12, 2 terms later, or we're going to call 2 jumps later, would be 48. A sub n minus 3 would be 3 terms before the 12, which would be 3 halves. Okay, so the subscripts are all with respect to what we're considering the A sub n. Okay. The sequences on an introduction sheet that we did yesterday can all be generated by a formula, which we did most of them. So whatever you are given that formula, how can you use it to generate the terms? So if we want the first 3 terms of a sequence, given the general formula that A sub n, so that would represent that any term is equal to negative 3n minus 7. So if I wanted the 50th term, that would be A sub 50, and I would substitute in 50 for n. Probably thinking, is it that easy? And you're right, it is. So if I want the first 3 terms, your first term would be represented by A sub 1, which would be negative 3 times 1 minus 7. A sub 2 would be negative 3 times 2 minus 7. And A sub 3 would be negative 3 times 3 minus 7. So when I evaluate these, negative 3 times 1 minus 7 would be negative 10. Negative 6 minus 7 would be negative 13. And negative 9 minus 7 would be negative 16. So those are the first 3 terms of the sequence. Now what are those going down by every time? You're right, they're going down by 3. So if you look at your A sub n formula, right here, negative 3 looks like the slope of a line if it was y equals mx plus b. that's exactly what this is. If this is an arithmetic sequence, and that number in front of n is going to represent the slope, which is going to give us that common difference we're looking for. Number 3, use the general formula. A sub n is 5 times 2 to the n plus 1 power to generate the first 3 terms of this sequence. So again, first 3 terms, the first term is a sub 1, the 1 represents the first term, would be 5 times 2 to the 1 plus 1. A sub 2 would be 5 times 2 to the 2 plus 1. And a sub 3 would be 5 times 2 to the 3 plus 1. So now, evaluating these, that would be 5 times 2 squared. So 2 squared is 4, 5 times 4 is 20. 2 to the 2 plus 1 is 8, 5 times 8 is 40. And 2 to the 3 plus 1 is 16, 5 times 16 is 80. So if we look and see how we're getting from each term, it looks like we are multiplying by 2, so it is a geometric sequence where right here, this 2 right there, if I have a 2 as an exponent, that's going to be what we are multiplying by. So this is a way we can write a general formula of a geometric sequence, is we figure out what the common ratio is, and that would go in parentheses to an n plus 1 power or an n power, depending on how we're going to write our sequence. Next one, 4, we're going to use the general formula a sub n to be 2n over n plus 3, so this is not geometric and it's not arithmetic, because it's not set up as an equation of a line or the power with a base to an exponent like number 3 was, to generate the 6th and 11th terms. So aka we're looking for a sub 6 and a sub 11. So we don't have to find any other terms than those if we have the general term. So a sub 6 would be 2 times 6 over 6 plus 3, which would be 12 over 9, or 4/3. And a sub 11 would be 2 times 11 over 11 plus 3, which would be 22 over 14, which reduces to 11 sevenths. Alright, so arithmetic sequences. So we discussed this yesterday, that an arithmetic sequence is going to have what's called a common difference. So each term after a sub 1 is the sum of the preceding term and the common difference. So to find d given a list of terms. So the common difference is going to be your a sub n term, whatever it may be, minus the a sub n minus 1 term. So in other words, this is whatever term minus the term before. So in our example here, you can take any term and subtract the term before it, and we have our common difference, d. Okay? And this is only if the sequence is arithmetic and you could tell that you are adding or subtracting the same thing every time. To find d given two non-consecutive terms, For example, say you're only given that the first term is 2 and the last term is 14, or the fourth term is 14, what you would do is similar to slope. So you would take the last term that you're given and you subtract the first term that you're given and you divide it by the amount of jumps or spaces in between those two given pieces of information. So in this case, we would take 14 minus the 2. That's the values of each term, and we divide it by how many spaces between, which in this case would be the 4 minus 1, because it's a sub 4 minus a sub 1, so that's all we have to do to subtract. So that would be 12 over 3, and that's how we can get the common difference to be 4. So that's two different ways that you're going to have to find a common difference, which will help us write the formulas as we move forward here. So sometimes you're given the first few terms, it's really easy to find, and another time you're going to be given one term and another term. And it could be the 50th term and the 70th term. You could still do it using the formula, take the 70th minus the 50th and divide by 20, basically, 70 minus 50. In a geometric sequence, we learned this yesterday, each term after the first a sub 1 is the product of the preceding term and the common ratio. So you're multiplying by something every time. So to find r, given a list of terms, it's like we did yesterday, and I showed you what to do, is you take any term and you divide by the term before it, which would be a sub n divided by a sub n minus 1. Okay. So any term divided by the term before. So in our geometric sequence above, your r, say I use 8 as any term, I just divide it by the term right before it, and I get 2. Now, so it's pretty easy if you're given a bunch of terms in order. But if you have to find your common ratio given two non-consecutive terms, just like above in that arithmetic, there's actually a formula for that. So what we would do is we take the last term that we're given, we divide by the first term that we're given, and we would take an nth root of that. That nth root is going to be how many jumps there are. So if you can squeeze the word jumps in that spot for what type of root this would be, you got an nth root. So what that's going to be, in this case, is 16 divided by 2, and there's 3 jumps. Actually, probably want to don't write the 3 there. Write that it's 4 minus 1. That's how you're always going to find that root. So 16 over 2 is 8, so this is going to be the cube root of 8, which is 2. So that's your common ratio. So that's when you're given two non-consecutive terms. Okay, so E has some examples. So we got 6 problems of examples, and then we have, that's weird, number 5 and 6 come after 5 and 6. Okay, whatever. All right, so identify as arithmetic or geometric and find the D or the R. So in number 1, going from 1 to 1/2 to 1/4. So going from 1 to 1/2, you're going down a half, and going from 1/2 to 1/4, you're going down a fourth. So that means this is not arithmetic. If I do 1/2 divided by 1, I get a half, and if I do 1/4 divided by 1/2, you would get 1/2. So this is definitely going to be geometric. If I took any term, your a sub 1, divided by a term before it, you get 1/2, which is the common ratio. So then writing in the next three terms, if I divide by a half, I'm going to get 1/8, 1/16, and 1/32. Number 2, going from 2 to 6 is up 4. Going from 6 to 10 is up 4. So this is arithmetic. And if I'm doing an arithmetic to find my common difference, I'm going to take my a sub n and subtract my a sub n minus 1, which in this case, let's go with 10 minus 6, which is 4. So that's going to be your D. Okay. So then my next three terms will be 14 and 18 and 22. Number 3, so going from 1 to 3/2 is going up a half. And going from 3/2 to 2 is also up a half. And if I was to divide them, you would not get the same thing both times. So this is going to be arithmetic. Okay. So if I just take my a sub n, any a sub n, and subtract the term before it, we are going to get 1/2. Which is the common difference. So just add a half every time. The common denominators are always nice. It looks like everything is in improper fractions. So I got 2/2, 3/2, 4/2. Next one's going to be 5/2, 6/2, which is 3, and then 7/2. Okay. Number 4, from 2 to 6, it goes up 4. From 6 to 18, it goes up more than 4. So this is definitely not arithmetic, but 6 divided by 2 is 3, and 18 divided by 6 is 3. So this is definitely going to be geometric. So my a sub n over my a sub n minus 1, 18 over 6 is equal to 3. So that's my r, so I'm just going to multiply by 3 every time. 18 times 3 is 54, times 3 is 162, and multiply that times 3. 162 times 3, let's see, times 2 is 224, so that's going to be 386. All right, number 5 with these fractions. If you look and see how it goes from positive to negative to positive to negative, that's a telltale sign that this does not have a chance to be arithmetic because it's not going to be going up or down the same amount. So the only chance here is this is going to be geometric if they want to find a D or an R. So if we take 8/9 and we divide by 4/3, which means we're going to be multiplying by 3/4, that's equal to 2/3. If I double check again and do 16/9, or 16/27, I mean, and I divide by 8/9, which means I'm multiplying by 9/8, you're going to get 2/3. So my common ratio, either way I look at this, my next term divided by the term before, it's going to be 2/3. But since you're alternating signs each time, your R value is going to be a negative 2/3. So since I'm multiplying by a negative 2/3 every time, I'll do that. So I got, next one would be a negative 32. 27 times 3 is 81. And then I got a positive 64. Multiply 81 times 3, I got 243. And then negative 128. 243 times 3 is 729. Number 6, r plus 2, next term is r minus 1, and then r minus 4. So what is this going down by every time? If you take your a sub n minus n, or a sub n minus your a sub n minus 1 term, that's r plus 2. Or not r plus 2, sorry. I'm distracted here. Dogs and kids all over the place. R minus 1 minus the r plus 2. So r minus r is nothing, and negative 1 minus 2 is negative 3. So it looks like you're going down 3 every time, so your common difference is negative 3. So this is definitely arithmetic. And just subtract 3 every time, so r minus 7, r minus 10, r minus 13 would be the next 3 terms of the sequence. Okay, next 2 problems kind of puts it kind of all together. So there's a couple things here. Find the sequence that has 4 arithmetic means between 25 and 60. 4 arithmetic means there are 4 numbers between 25 and 60 that'll make this an arithmetic sequence. So if they're between 25 and 60, you're going to have 25, comma something, 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 and something. There's 4 arithmetic means between 25 and 60. So what I have to do is figure out what the common difference is going to be. That common difference we could figure out by just doing the formula that we already did with those jumps. So this 25, that's our a sub 1, and the 60 is our a sub 6. 60 is the 6th term if there's 4 arithmetic means between 2 numbers. So to figure out what the common difference is going to be, we take 60, we subtract 25, and we divide by how many jumps there are, which in this case would be 6 minus 1. So that's 35 over 5, or 7. So that's your common difference. So the 4 arithmetic means, I'm just going to add 7 every time. So you get 32, 39, 46, and 53. And 6 is a similar example, but it's a geometric sequence. So we want to find 3 geometric means that are between 9 and 16 ninths. So we'll write this out. So 9 is the first term, and then I got 3 geometric means before you get to 16 ninths. So we need to consider the 9 to be our a sub 1. Then we got a sub 2, a sub 3, a sub 4, and this would be a sub 5. Okay. So, to figure out again what the common ratio is going to be, we're going to use that formula. And that formula is going to be the nth root, so there are 4 jumps, and we got to take 16/9 and divide by 9. So this is going to be the 4th root of 16 over 81. The 4th root of 16 is 2, and the 4th root of 81 is 3. So we're going to be multiplying, so we just found that 2/3 is the R value. So we're going to be multiplying every term by 2/3. So 9 times 2/3 is 18/3, or 6. 6 times 2/3 would be 12/3, or 4. 4 times 2/3 would be 8/3, and 8/3 times 2/3 is 16/9. Okay, so then these notes correspond with worksheet 1, which would be tonight's homework assignment. I will place the solutions to this homework assignment in a folder inside of this chapter on Schoology, so you can check and make sure that you have this down for tomorrow when we move on to day 2. Have a good rest of your day.